Hello, my friends. Today we're doing section 1.5 in review, and that's quadratics. So if you have an equation, ax squared plus bx plus c equals 0, there are three basic ways you could solve this. Now, again, I'm assuming that this is all a review. I'm not teaching it for the first time, so I'm just stating things that you hopefully have learned already. If you remember them, great. If you don't remember them, well, that's why I'm giving it to you all right now. So at the end, we'll all be up to speed. So one method is to factor. I'll get into detail on that. Second method is completing the square, which I'm not going to do in this video. And the third method, this is what we feed to baby parabolas. We feed them quadratic formula. Okay, now, of course, this is a video, but I know you're all laughing hysterically at quadratic formula, get it, baby parabolas. Anyway, factoring a parabola. Let's say we have, factoring a quadratic. Let's say we have x squared minus x minus 2 equals 0. So if this factors, we want two numbers that multiply to -2, add up to -1, and that would be +1 minus 2. And I set each factor. Now the idea is that if two things multiply out and wind up equaling 0, either one or both of them have to equal 0. So if x plus 1 equals 0, then that's gonna make the whole thing. That's gonna make the product equal 0. Well, that'll happen when x equals -1. And if x minus 2 equals 0, that will also make the product equal 0. And that happens when x equals 2. So I have two solutions. I have two zeros, if you will, or two solutions of this quadratic equation. That was the first method. The second method is called the quadratic formula. Now, quadratic formula is this big ugly formula, which I think is beautiful, but it's this big formula. I just want to make one quick point. Factoring, I think, is the easiest list, and it's my favorite way to solve a quadratic. But not every quadratic can be factored. Some can, some cannot. But quadratic formula always works. Completing the square also always works, by the way. But again, we're going to do quadratic formula. So the quadratic formula is, and you've probably seen this before, the quadratic formula is that if you have for a quadratic, if you have given that ax squared plus bx plus c equals 0, then x is going to equal, to make this equal 0, x is going to equal -b, whatever that number is in front of x, plus or minus, because there are two solutions, the square root of b squared minus 4ac over 2a. And that's a quadratic formula. One of my students told me there was a negative boy who was undecided whether he would go to a radical party. He decided to be square, and he missed out on meeting 4 awesome chicks. It was over at 2 a.m. That was how it was said to me. Anyways, let's take the same problem now, and let's solve it with quadratic formula, just to show you that we'll get the same answers. So first thing we have to do is identify what's A, what's the B, and what's the C. So I'm going to rewrite this just to make it more obvious. I'm going to write 1x squared minus 1x minus 2. So the A is 1. B is -1. And the C is -2. Now I'm going to plug that into the formula. And I'm going to get the x values that make this equal 0. The x values that make this whole thing equal 0 is going to be -b. So -b is -1, so it's +1, plus or minus the square root of b squared. Now, -1 squared is just +1, minus 4 times 1, because that's a, times C, which is -2, over 2A, which is 2 times 1. Now, this becomes 1 plus or minus the square root of 1 plus 8 over 2, which is 1 plus or minus the square root of 9 over 2, which equals 1 plus or minus 3 over 2. Now, this is not one answer. This is how we often give the answer, but this is not one answer. This is two answers. The plus 3 is one answer. The minus 3 is a different answer. So the answers, if I list them out, is 1 plus 3 over 2, which is 4 over 2, which is 2. And then the other answer is 1 minus 3 over 2, which is -2 over 2, which is -1. So notice I got +2 and -1. Here I got +2 and -1, the same answers. So quadratic formula gave me the same answers. Now, if I'm not sure if you would have taken this already, or even if you have, if you remember this, but there's something called the fundamental theorem of algebra, which is that if you have a polynomial, the most answers, the most zeros it could have is the degree of the polynomial. So a degree polynomial, because of the x squared, can have the most two answers. We got the two answers, that's fine. But sometimes a quadratic has less than two answers. Sometimes it only has one answer. And when would that happen? Well, but how could it be? There's a plus answer and a minus answer. How can it only be one? Well, if the radical winds up being a 0, so I'm going to have a +0 and a -0. It's going to be the same answer. Let me give you an example of what I'm talking about. So here's an example. X squared minus 6x plus 9 equals 0. So let's do quadratic. Well, there's two. Of course, this can be factored. But I want to do quadratic formula right now. So quadratic formula would be -6, which is +6, plus or minus the square root of 36, because it's -6 squared, minus 4 times 9 over 2, which is 6 plus or minus 0 over 2, which is just 6 over 2, which is 3, and that's it, just one answer. Now, by the way, we could have gotten that one answer by factoring this. We want two numbers that multiply to 9 and add up to -6, and that would be x minus 3 squared equals 0. So my point is that the number that's inside the radical, and there's a fancy name for that, it's called the discriminant, but that number inside the radical, if it's a 0, I'm only going to have one solution. When I have if it's not 0, like over here, I'm going to have two solutions. If it is 0, I'm going to have one solution. But what if it's, in the example I gave, the number came out to +9. What if the number comes out? What if it comes out to a negative? What about then? So let's look at that right now. Let's do another example here. X squared minus x minus 1 equals 0. So x is going to be 1 plus or minus the square root. I'm sorry, I meant to be +1. X plus 1 plus or minus the square root of b squared, which is -1 squared, which is 1, minus 4 times 1 times 1, which is just 4, over 2, and this just equals 1 plus or minus square root of -3 over 2, which is equal to 1 plus or minus rad 3i over 2. Now, there are still two zeros. There's still two roots of the equation, 2 zeros. When the number inside the radical, again, that's called a discriminant. When that number inside the radical is a positive number, then I have two real solutions. Actually, let me write this on the. If b squared minus 4ac, if it's greater than 0, then two real solutions. If b squared minus 4ac equals 0, then you have one real solution. If b squared minus 4ac is less than 0, it's a negative number, then you're going to have two imaginary solutions. Or I should say complex solutions. And that's the story. Now let's what does that look like on a graph? What does it look like on a graph? So I'm going to switch cameras now. I'm going to go to Desmos. Here we go. Hi everybody, it's me. Let's go to Desmos. Okay. I don't want any of this yet. Okay, so we have here. Let's look at what we had here. I want to take I'm just going to type in the three parabolas that we graphed on the other page just a minute ago. So we had x squared. I'll make these other ones, Susie, I want to make these other ones disappear. We'll look at these guys later, but not now. All right, so the first example we did was x squared minus x minus 2. And we had, so b squared minus 4ac came out to, in that case, that was when it came out to positive 9. And I got -1 and positive 2 as my solutions. The next example we had was x squared minus 6x plus 9. And there we had one solution. Let me just make that for a second. So when there's one solution, that means it just kind of like it just like kisses the x-axis. It's just, or I could say it's tangent to the x-axis. And the other possibility we had was the last problem we had, x squared minus x plus 1. This is one where it was a negative number inside the radical, x squared minus x plus 1. And if you notice, it misses the x-axis completely. It never touches the x-axis. And the reason is because there's no real, because when it touches the x-axis, the points where it touches the x-axis are the real x values that make this equal 0. But there are no real x values that make x equal 0. So the parabola is up in the air. There are imaginary values, but not real values. So that's kind of cool graphically. So that's these guys right here. All right, now I wanted to mention couple more things before I start looking at Desmos too much. So let's go back to the other. Okay. Back to our parabola. Y equals ax squared plus bx plus c. So y equals ax squared plus bx plus c. How do you figure out? So first of all, if a is positive, we're going to have a happy parabola. When a is negative, we're going to have a sad parabola, an upside down parabola. And I'm going to show you. I'll show you that very clearly on Desmos, how what that looks like. But how do you find the vertex of a parabola? Well, if you took algebra, you may or may not have learned, and you may or may not remember, there's a formula for the vertex of a parabola, and that is the x value of the vertex is going to equal -b over 2a. So let's do an example here. Suppose we have y. Suppose we have y equals x, x squared minus 6x minus minus 8. So what is the vertex? Now I could factor this, but I don't know how much is gonna, it'll show me where the zeros are, but it ain't gonna really show, this factors, by the way, to x minus 8 times x plus 2, but that doesn't, oh, I'm sorry. I meant for that to be a 16, sir. But that doesn't really help me in terms of, that doesn't really, what happened? I was thinking of the x minus 8 in the solution of the factoring, and so since I had 8 in my mind, I wound up writing 8 over there. So that happens sometimes. Sometimes you have something on your mind. I meant to write 16, but I was thinking about an 8, so I just wrote the 8. Um, so the vertex would be, the x value of the vertex would be negative 6, which is positive 6, over 2 times 1, which is 6 over 2, which is 3. The vertex is going to be 3 comma something. Well, what is the something? How do we get the something? Well, to get the something, you just take the 3 and you plug that into your original quadratic. So I'm going to look, so the y value of the vertex is going to be 3 squared minus 6 times 3 minus 16, which is 9 minus 18 minus 16. Well, that's a big number. That's what's that, 34 or 32? 34. So it's 9 minus 34, which is negative 25. The vertex is 3 comma negative 25. Oh, I really want to. Okay. Um, let's go to Desmos a little bit now, and just get some visuals on these parabolas. Okay, so we have here the switch cameras. All right. So looking at y equals ax squared plus bx, we'll see. So the problem we just had, 16. Let's say, okay. So the problem we just had a second ago was x squared. So a was 1. Minus 6x. So b was b. So b was negative 6. And c was minus 16. So c was negative 16. C. Oh, I want c to be. C is going to be negative 16. So A was 1, B was negative 6. This thing's bothering me for a minute. I want to get rid of this. I just want to confuse. I don't confuse you. Show you two things at a time. This is the equation we're looking at. So A is 1, B is negative 6, C is negative 16. Let's just find the vertex. The vertex is, that'd be 3, negative 25. And sure enough, the vertex is 3, comma, negative 25. The y-intercept is negative 16, which is what I said. It's just always the c value. And we have our intercepts are negative 2, 0, and 8, comma 0, which is what we saw. We saw that when we factored it out, by the way. And if we do quadratic formula, we will get a positive discriminant. We will get a positive discriminant if we would do quadratic formula on that. But I want to show now is what exactly do the let's set it all back to 0 now. I want to show you a little visually what the different ABCs, what they do to this parabola. Okay, so the A does the same as what it always did. The A does the same as what it always did. When the A is a larger positive number, it stretches it, flattens it, and then it stretches it vertically, and then it flattens it when it goes down to 0, and then it stretches it vertically negative when it's negative. So this is similar to what we've seen A do with other examples. So let me set that back to 1. The C just basically goes straight up and straight down, just like it always did. C just has to go straight up, straight down, just like the K in a previous video. And let's stop the C. Okay. Now the B, that's always the fun one. It makes it go in all kinds of weird ways. It goes up, down, sideways. It's kind of parabolic actually when you think about it. But it's actually kind of interesting. So that's what B does to it. Alrighty. And let me just okay. So let me set B back to okay, so that's just what the thing. Now let's do that. Let's see if A is 1 and let's say C is 1. So notice that it doesn't touch the axis. It doesn't touch. Oh, let's look at the example we had before. It was x squared minus x plus 1. So let's so x squared minus x plus 1, that's B is negative 1, and C is positive 1. And notice that it never touches the axis, never touches the x-axis. You can get the vertex by doing the negative B over 2A, but the vertex never touches the x-axis. And that's that. Now, I want to show you a whole different way to write a quadratic, which has its own advantages and disadvantages. So let's stop the share for a second. I'm going to go switch to my other camera. Switch to the other camera. And now we're going to look at another way to write a quadratic, which again has its own advantages and disadvantages. Another way to write a parabola is y equals a times x minus h squared plus k. For example, y equals 2 times x minus 5 squared minus 3. Now, what's nice about this is that the vertex, I could see immediately, is going to be h comma k. So the vertex in this example is going to be, 5 comma 3. I'm sorry, negative 3. 5 comma negative, because it's x minus h, so it's minus h is 5, and k, which is the negative 3, plus k, so it's plus the negative 3. So the vertex is 5 comma negative 3. So the vertex just pops right out. You can't do quadratic. There's no quadratic formula here. Now that's the thing. In terms of finding the x-intercepts and the y-intercepts, I can't just look at the last number. I can't. There's no quadratic formula. It's not that hard. If you want to find the x-intercept, you just set y equal to 0. I'll add 3 to each side. And again, it's going to solve it, but it'll be relatively easy to solve. So I'm going to get 3 equals 2 times x minus 5 squared. And I divide both sides by 2. So I get And then, so I have 3 halves equals x minus 5 squared. Now I square root each side. So I get x minus 5 equals plus or minus the square root of 3 halves, because I have to be open to the positive or the negative. And now I add 5 to each side. I get x equals 5 plus or minus the square root of 3 halves. So getting solid, and these are the zeros. These are the zeros of the equation. So it wasn't super hard. It wasn't as hard as factoring or anything like that. But that's the now if I want to find the y, if I want to find when y equals 0, these are the x-intercepts. If I want to find the y-intercepts, to find the y-intercepts, I would just add x equals 0. So y equals 2 times 0 minus 5 squared minus 3, which is 2 times 25 minus 3, which is 50, minus 3, which is 47. So the y-intercept is going to be equal to 47. And that's the story. Now, let me just show you on Desmos what that looks like with the H and the A and the H and the K. And by the way, we're going to have the same. The A is going to be similar to what we had before, meaning that if A is greater than 0, then it's going to be a happy, smiley parabola. And if A is less than 0, it's going to be a sad parabola. If A equals 0, then it's just a flat line. We want to talk about. Anyway, so let's check this out here. I just wanted to we do this. Let's switch cameras and let's share my screen. Let's see if I can. Okay, so I don't need the BC anymore. So I don't need the BC anymore. I don't need these guys either. All right, so let's just have what we need. Okay, so the A, let's set A back to 1. We're going to set A back to 1. And I'm going to set H and K back to 0 just for now. Okay. So the A is going to be similar to before. When A is big, it's stretched vertically. When A is small, it gets close to 0. When A is negative, it goes upside down. So it's frowny. So that's what the A does. You can see visually what the A does. As A gets big, it gets stretched a lot positively. When A is a big negative number, it gets stretched a lot vertically. When A is relatively small, it gets close to the x-axis. And when A equals 0, it's just a total flat line. So that's A. Now let's look at let's set A back. I just want to set A back to 1. Now the H just moves it just horizontally, just like we had in a previous video with the general functions. The H, that's all the H does. And the K just moves it straight up and straight down. And that's the story. And that's my H and that's my K. Now, one nice thing here is that notice I stopped it when H is negative 2.91 and H and K is positive 2.75. I just happened to pick those numbers. I just happened to stop it there randomly. Well, what is the vertex of the parabola? Look at that, negative 2.91, 2.75. So the H and the K is instantly the vertex of the parabola. That's a very cool thing. That just makes things very easy and very inconvenient. So that's a really nice thing. Well, I think that's beautiful. I'm ending this video on a happy note. And may all your parabolas be good ones. Okay, bye everybody. It's been loads of fun. Bye.